Welcome to Lecture 1 for College Algebra, MAC 1105. My name is Jorge and I am the instructor for this course. So Lecture 1, we're going to talk about linear equations and solving linear equations. So we have several objectives for the first lecture. The first thing is we're going to learn how to solve a linear equation. And the second thing is we're going to talk about equations that lead to linear equations. So the first thing is that here we have some procedures that result in equivalent equations. So the first one is if I interchange the two sides of the equation, so I replace 3 equals x by x equals 3, those are equivalent. Or if I simplify the sides of the equation by combining like terms or eliminating parentheses and so on. So I replace parentheses x plus 2 plus 6 equals 2x plus in parentheses x plus 1 with x plus 8 equals 3x plus 1. So all I did was simplify both sides. They're still equivalent equations. Number 3, either add or subtract the same expression on both sides of the equation. So I have 3x minus 5 equals 4, and I replace that with 3x minus 5 plus 5 in both sides of the equation, so they're still equivalent. Or number 4, if you multiply or divide both sides of the equation by the same non-zero expression, you end up with an equivalent equation. And then number 5 is if one side of the equation is 0 and the other side can be factored, then we may use what is called the zero product property and then set each factor equal to 0, and we still end up with equivalent equation. So here we have the first example. So we're going to solve the equation 4x minus 7 equals 13. So the first thing that we're going to do is we're going to go ahead and add 7 to both sides. And the reason we do that is because since we have the 4x on the left-hand side, and we have a negative 7 there, so if we add 7, we can get rid of that 7. So if we add 7 to both sides, now we end up with 4x equals 20, because 13 plus 7 is 20. So now at this point in time, what we do is we divide both sides by 4, and of course on the left side, the 4's cancel out, and then 20 divided by 4 equals 5. So the original equation, 4x minus 7 equals 13, we were looking for the value of x that's going to make it a true statement, and we ended up with 5. So now what we have to do is check it to make sure that it is in fact correct. So here what we do is we substitute the value that we got, 5, with x. So 4 times 5 minus 7 equals 13, and of course 4 times 5 is 20, and then 20 minus 7 is in fact 13. So the solution to this equation is in fact x equals 5. So here we have a definition. In a linear equation, one variable is equivalent to an equation of the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. So here we have another linear equation. So we're going to go ahead and solve this one. So this is 1/3 times x minus 1 minus 3 equals 1/4 times 3x plus 2. So here the first thing that we do is we multiply both sides by 12. And the reason we do that is because the common denominator between 3 and 4 is 12. So by multiplying both sides by 12, we're able to get rid of the fraction. So now we see that we end up with a 4. Now, how do we get a 4? So if I do 12 times 1/3, I do 12 times 1, which is 12 divided by 3, and that gives me the 4. On the other side, I get 12 times 1/4, so 12 times 1 is 12, 12 divided by 4 is 3, so that's how I end up with the 3 here in front of the parentheses of 3x plus 2. So now I have an equation that I've seen many times before. This is just a simple linear equation. And here now, what happens is that we multiply the 3 times the 12. The reason we multiply that is because the 1/3 times x minus 1 is a factor, is a term, and then the negative 3 is also a term. So when you do distributive property, you have to multiply by all the terms. So now here I can go ahead and simplify this equation. So I end up with 4x minus 40 equals 9x plus 6. And then what I can do is just add 40 and subtract 9x from both sides. And by doing this, what happens is that I move all of the terms with the variable to the left side, and then I move all my constants to the right side. So then now we end up with negative 5x equals 46. So how do we end up here? Well, on the left side, the negative 40 plus the 40, they cancel each other out. 4x minus 9x, we end up with negative 5x. And then, of course, the 9 on the right side, the 9x minus 9x, they cancel each other out. And then 6 plus 40 is 46. So now we're going to go ahead and divide both sides by negative 5. And then we're going to end up with x equals negative 46 over 5. So at this point in time, what we're going to do is we're going to go ahead and check this to make sure that this is in fact the solution. So here we have the original equation. So here we have the solution that we came up with. And if we substitute that in the original equation, in every place that we see an x, we end up with what we have here now. So now what we do is we just start evaluating piece by piece. So now we have here, oh, let me go back here real quick. So negative 46 over 5 minus 1. What happens with the 1 is, since I have a negative 46 over 5, I can turn the 1 into a fraction that has a 5 in the denominator. And 5 over 5 is equivalent to 1. And then if you notice with the 2, the 10 over 5 on all the way to the right side, again, 10 divided by 5 is 2, so those are equivalent to each other. So then that puts us here where we are at this spot. So now negative 46 over 5 minus 5 over 5 ends up being negative 51 over 5. And then, of course, on the right side, we end up with negative 138 over 5. And, of course, we still have the 10 over 5. So now what we're going to do is we're going to go ahead and, on the right side, we did negative 138 over 5 plus 10 over 5, which gave us negative 128 over 5. And at this point in time, we're just going to go ahead and multiply out the 1/3 and the 1/4. So 1/3 times negative 51 over 5 is equivalent to negative 51 over 15. 1/4 times negative 128 over 5 gives us negative 128 over 20. So 3 times 5 is 15, and 4 times 5 is 20. So now what we're going to do is we're just going to have to do something with that 3. And since we have a 15 in the denominator, we're looking for a fraction that's equivalent to 3. So 45 over 15 is equal to 3. So now I can just go ahead and subtract the left side. And I'm going to end up with negative 96 over 15 equals negative 128 over 20. So if these two sides are equivalent, then x equals negative 46 over 5 is in fact my solution to this equation. And what I find out is that they are in fact equivalent to each other. So therefore, our solution, or the value that makes this a true statement, is in fact x equals negative 46 over 5. So here we have a solution or an equation. So 3.81x plus 4 over 12.2.31 equals 23.03. So we're going to round the answer to 2 decimal places. So then what we do is just simply move all of the constants to one side. So we take the 4 over 12.231 and move it over to the right side. So now we're going to go ahead and combine those. Actually, we're going to divide both sides by 3.81. So when we have decimals like this, probably the easiest thing to do is to use a calculator. So the first step is we have the original equation. Now we have the second equation where we move the constant to the right side. And then we simply just divided everything by 3.81. And if we use a calculator to solve this, what you want to do first is you want to divide. So you want to do 4 divided by the 12.231, then you subtract it, and then you divide. So just make sure you follow order of operations. And then the solution that we get is approximately 5.96. And these are problems that they're just easier to solve if we use a calculator. So here we have another linear equation. So we have x plus 4 times x minus 2 equals 3x plus 2 times x minus 4. So the first thing that we're going to do is go ahead and do distributive property. So we do 4 times x, which is 4x, and 4 times 2, which is negative 8. And then 2 times x, which is 2x, and then 2 times negative 4, which is negative 8. And then we start combining like terms. So we're going to combine the x plus the 4x and the 3x and the 2x. And then that gives us 5x minus 8 equals 5x minus 8. So what happens at this point in time is if we add 8 to both sides, we end up with 5x equals 5x. So now this is what we call an identity. Now we could have seen that 2 steps previously when we ended up with the 5x minus 8 equals 5x minus 8. And this is an identity because it does not matter the value that we substitute into this equation, we're going to end up with the equivalent values on both sides. So whether I substitute x with 2, I end up with 10 equals 10. Or I substitute x with negative 2, I end up with negative 10 equals negative 10. Or if I substitute x with 1/5, I end up with 1 equals 1. So this is why it's an identity. Regardless of the value that we substitute the variable with, we end up with the same value on both sides. So here we have another equation. So the first thing that we're going to do again is do distributive property. So we distribute the 2 and the 6. And then now we're going to go ahead and combine like terms. So here 4x plus 2x is 6x, and negative 9 plus 16 is 7. And then 1 plus 24 is 25. So we end up with 6x plus 7 equals 6x plus 25. So if we subtract 6x from both sides, we end up with 7 equals 25. Well, that doesn't make any sense. So since 7 does not equal 25, this is an equation that does not have a solution. So there is no value, there's no real number that we can substitute in here that's going to give us the same value on both sides of the equal sign. So therefore, this is no solution. So here we have an applied problem. We're going to convert Fahrenheit from Celsius. So in the United States, we measure temperature in both degrees Fahrenheit and degrees Celsius. Now they're related by the formula of C equals 5 over 9 times F minus 32. So what are the Fahrenheit temperatures corresponding to the Celsius temperatures of negative 10 degrees, 0 degrees, and 40 degrees? So then what we do is we simply, here, since we're solving for F, what we're going to do is we have to have F by itself, right? Now, there's several ways that we can do this. So the first thing that we did is we multiplied both sides by 9 to move the 9 over to the left side. And then we went ahead and distributed the 5. So 5 times F is 5F, and 5 times negative 32 is negative 160. And then here now what we do is we just add the 160 to both sides, and then we solve for F. So now, so the first equation, C equals 5/9 times F minus 32. This is solving for Celsius given that we have the Fahrenheit. Now, if we have Celsius and we need to solve for Fahrenheit, we use the equation that we just came up with, which is F is equal to 9/5 C plus 32. So now we can substitute these values, negative 10, 0, and 40, into this equation. So when the degrees is negative 10 degrees Celsius, the corresponding Fahrenheit temperature is 14 degrees Fahrenheit. When it's 0 degrees Celsius, the corresponding temperature is 32 degrees Fahrenheit. And when it's 40 degrees Celsius, the corresponding temperature is 104 degrees Fahrenheit. And so in the next video, what we'll do is solve some applied problems. This is the end of the first part for lecture 1. Thank you.